Hello everyone, this is Hossein Mohit. Welcome to the Introduction to SQL video lecture. In this session, you will be introduced to SQL or structured query language and get a chance to start working with an actual database and learn some basics. So at first, SQL might seem a bit intimidating and difficult for you, but don't worry, this lecture is just to introduce you to the database management system environment and the SQL language. You will begin to understand the logic behind the SQL and the structure that makes it works for you. Future chapters and lectures will dive deeper, giving you a more comprehensive understanding of the SQL and enabling you to kind of write more complex queries. So just please remember, this is just a quick overview of the chapter. It's not at all enough on its own to help you to ace your quizzes, assignments, and exams. So to pass this course successfully, you will need to read the chapter and complete the queries and assignments provided. So SQL or structured query language is a standard language used for extracting data from relational database and answering questions based on the data. It is primarily known as a query language because querying databases and answering business questions using data has widespread applications and demand in the market. However, SQL is almost used for other tasks, such as manipulating data, creating database schemas, setting up tables, entering, changing the data, and also deleting the data, and also creating different views for the data. So in summary, anything you want to do within database management system, you need to do it through SQL. It is the language for interacting with these type of systems. So in this chapter, you will be working with the databases from the Red Cat Shoes business, which is an online shoe store. You will be using a simplified version of this database, which is much less complex than the full version of the Red Cat Shoes database. So the key entities or tables you will be working within this chapter include the product table, which is information about the shoe products, customer table related to the detail about the store's loyal customers and manufacturers and suppliers table, which gives you information about the suppliers, and the sales table, which have some data regarding the sales transactions. So the actual version of this database available on the book platform contain more table and additional complexities that aren't included in this chapter. Some typical business questions that might arise when you are using this database and can be answered using this database include, for example, which products are selling the best and which are selling the worst, or for example, which days of the week are sales is the highest, or for example, which days do you have the most visitors on your websites, or which manufacturers is the most popular among the suppliers, or who are the customers that visit your website often but don't make purchases. So these type of questions can be answered using the complete Red Cat Shoe database, but the simplified version used in this chapter will also allow you to find answers to many type of questions that you have. So as I mentioned, you will be working with the simplified version of the Red Cat database, also referred to as a Red Cat 1. So here is an example of the simplified sales table, which include columns or attributes such as sales date, first name, last name, product name, category, color, item size, manufacturer name, and price. So one of the best feature of this textbook is it that all the embedded query boxes. So these allow you to apply what you are learning directly to the platform without needing to log into the separate system. You can learn concepts and immediately practice them in the same space. You can also click on the Advanced Editor to access advanced editing functions. So here you can see in the editing window, you can choose your database. So in this course, we will working with the MySQL, but you have the option to select other database management system as well to see how your SQL code might behave differently. Uh, so almost most of the SQL code, especially for the select statements or main statement, they are quite similar across the different systems. Differences may arise when it comes to data manipulation, table creation, or defining data type. Also here on the credentials section, you have the option to select your database management system. So you can use your student account credential, and with your student database, you will have an empty database where you can create any tables or schemas you want. It's a blank canvas for your practice where you can recreate a database, which we will study in this course. So there are also several databases associated in this course, including Redcat 1, Redcat 2, Food Inspection, Lorenzo, Hudson University, and most of the course material is based on the Redcat 1 and Redcat 2, but scenarios and data for the other databases also available to you. So I have access to your database as well. Uh, so I can see what you're doing. You'll need to use your own databases for the assignments, and I can view the table and the schema you were created based on your work. So that's the advanced section. So within these embedded query boxes, you can also modify the query text and see what happens when you run the query. You will get the results right there in the same space. So this feature, as I mentioned in the first video as well, is one of the main reason I chose the textbook for you in this class. So it provides a seamless way to learn and practice SQL. So a SQL language is composed of different statements, and each statement can have multiple clauses. Each clauses start with the SQL keyword or reserved words. So these keywords are typically shown in all caps, and they are all in blue font color. Though the color can vary depending on the database management system you are using. In this textbook, I believe they are mostly shown in the green. Keywords usually have the different color compared to the other words within the statement, and they are all reserved, meaning you that they cannot use them for anything else. Depending on the clause and the purpose of the keyword, it is typically followed by the sequence of the column names, computations, or literal or table names, or even conditions. So the select statement is the most frequently used statement in SQL. It is primarily used for querying or retrieving data from the database, and it has several clauses such as from, where, distinct, group by, having, and finally order by. So in this chapter, we are going to learn about the from and where clauses, but you will review and learn more about the other clauses of the selected statements as well. You can also use the wildcards with your statements. For example, the asterisk signs wildcard refers to all columns or everything in the data. Each statement in SQL should end with semicolon. So the embedded query editor in your textbook will insert the semicolon for you, but there are some database management systems that don't do this automatically. So if you think you have created the statement correctly and but it doesn't run as expected, it might because you are forgetting to put a semicolon. So let's go to the where clause. So the where clause is one of the most important clauses in a select statement. The where clause is where you define the condition that must be met for data retrieval. It includes operators such as and, or, and not, as well as comparison operators. So these are the same logical operators used in a mathematical logic and follow the same order of the precedence. So, for example, a not has the highest precedence, followed by and then or. It is recommended to always use parentheses to make sure the order of the precedence clear and to ensure that your conditions are evaluated in the correct order, actually. I will review these logical operators and their relationships in a later slides when you will go over a few examples of the where clause and where clause in a select statement. But before I show you the actual queries, let's take a look at the table structure or entity relationship diagram, ERD, for the simplified Red Cat 1 database. We have four main tables, customer, product, sales, and manufacturers table, and you can see how they are related to each other. You will learn more about these relationships in the future chapters, but for now, just get a basic understanding of these tables, their columns or attributes, uh, and how they are connected is important. So we can query a single table, for example, to find all the sales in the sneakers category. However, in many cases, we need to use multiple tables and take advantage of the relationship between them to query and get results from those tables. This use of multiple tables in queries is called a join query. In the real world, most queries will involve some form of join because of the normalization process, which you will learn more about the normalization later. But for now, normalization means we can't store all our data in one table. Instead, we need to spread all of the data across different tables. You must be able to link these tables and get your answer by querying across them. For example, to list the sales of sneakers, you could simply query the simplified sales table by selecting everything from this table where the category equals to sneakers, like the one that you are seeing in the first part of the code. This query would give you all the sales for the sneakers from the simplified sales table. So we call it select asterisk from simplified sales where category equal to sneakers. However, if you want to achieve the same result using the full database, which is not be equal to the simplified version, you would need to use a join statement. Here you would start by selecting everything from the sales table, then join it with the product table based on the product ID. This is because the product ID is the key attribute that connects the sales table to the product tables, identifying what was sold. You would then add the condition where the category equals to sneakers. So as you can see in the code, it says select asterisk from the sale, which join the product through the product ID in the sales table and also product ID from the product table, where the category is equal to sneakers. You will learn more about the logic behind join queries in future chapters, but remember that is all in most situations when you are writing a query, it will involve some kinds of join queries. So this join process works because there is a shared column or shared attribute between two tables. In this case, the shared column is called product ID. So in the product table, product ID is linked to the product details like product name and descriptions. And in the sale table on the left side, as we can see, we have sale ID and product ID because each sale can involve multiple products. So when we perform a join between the sale and product tables using the product ID attribute, the database management system for matching product ID values, looks for matching product ID values in both table and retrieves the record and share these IDs. So uh, let's be more specific regarding this one. So the result, as we can see, has four columns, two from the sales table and two from the product table. And the product ID column appear twice in the result because one is for the sale table. As we can see, it's a sale dot product ID, and the other one is from the product table. So we can see it's a product dot product ID. And in each row, both product ID column have the same value. So as we see here, the row for product ID 10 appears twice in the result because there are two sales record within product ID 10. But as we can see, the row for product ID 30 does not appear in the result because there are no sales records with the product ID 30 in the sale table. So similarly, we can also join more than two tables. You can join three, four, or even more, while the queries become more complex and they are very common in real-world applications. In this example, we want to list the sales of sneakers that were made in New Jersey by manufacturers located in New Jersey. So to do this, we first select all columns from the sales table. So we write it as a sale dot asterisk. And also we select the category and manufacturer name and state column from the product and manufacturer tables. Then from sales, we start to join the sale table with the product table using product ID, then join product table with the manufacturer table using manufacturer ID. And finally, in the last line, we apply the condition where category is sneakers and estates is New Jersey. So this and between the categories and the state, it means both of these conditions should be true at the same time. So as you probably figured out by now, SQL statement can get really complicated, especially when many tables are involved. So a very good practice to use this to kinds of face this challenge is to use aliases. So short names for table or columns. Once things get more complicated, you can refer to these aliases instead of using the full table or column name. For example, we are defining S as an alias for the sale table, and for example, P for the product and M for the manufacturer. And we need to know that these aliases don't have to be a single letter. They can be a word or phrase. But here we are just use the alphabet, a character, as I mentioned, S for sale, P for product, M for manufacturer. So within the join statement, we use these aliases. So for example, s.product ID refers to the product ID from the sales table, and p.product ID refers to the product ID from the product table. Similarly, so m dot manufacturer ID refers to the manufacturer ID from the manufacturer table. So the query then say p dot manufacturer ID equal to m dot manufacturer ID, which means manufacturer ID field from the product table should match the manufacturer ID field from the manufacturer table. Finally, In the last line, the where condition, both condition category uh, for sneakers and state equal to New Jersey must be true for the query to return the results. So since we are on this subject, let's quickly review logical operators, not, and, or. So and is a exclusive operator, meaning that both condition must be true for the entire statement to be true. So if the either condition is false, the result will be false. You can see this in the table on the top left. Or is more inclusive. For an or condition to be true, only one of the conditions needs to be true. The only times that an or condition or statements is false is when both sides of the condition are false. So false, false equals the result is going to be false. And the last one, not, is a logical uh, negation. So, for example, it simply inverts the true values. So if something is not true, it is false. And if something is not false, it is true. So throughout to the end of this chapter, you will also get a peek into how you can update your database and data using SQL statements. There are a few different statements used for data manipulation and data modifications, with the most important one being insert, update, and delete. So with insert, you have the insert into a statement, which can also create table from scratch. You will have insert into table name, and then you will give it a list of columns and provide the values. You can also have insert into for an existing table name, where you give it the name of the existing table. If the table already exists, it will not create a new table. But if there is a mistake in the table name, the insert into might create a new table in your database. So you need to be careful with the table name. With insert into, you can also use the select statement in combination, which allow you to create a new table using a query or to populate an existing table using the query. For example, insert into an existing table name and then having the select statement, and the query will go ahead and select some columns or maybe all of the columns if you use a wildcard, those asterisks I mentioned, from a specific table where the conditions are met. And the last two, the update and delete statements, are used for updating rows and deleting rows, respectively. So removing, and also they can be used for removing values. Remember, each of these statements can only affect one table at a time, okay? So their detailed structure can differ based on the database management systems. Most database management systems follow the same standard for the select statement, but they can be differ and how they handle insert, update, and delete. So here are example of the structure for update and delete queries, or update and delete queries statement that we have. So for update, you can use something like update the table name and set the column one to, for example, this value, set the column two to the that value, where column names is equal to some other values, okay? So this allow you to precisely pinpoint which specific value with each column should be updated. So for the delete, you might use the delete from table name where condition is something. So the delete statement removes row based on the condition provided. And additionally, the drop statement will go ahead and delete the entire table, not just specific rows. So there is no undo function in SQL, so you need to be careful about it. And when you are using the drop statement, you need to make sure that You are using it when you are rebuilding tables and needs to remove earlier version of the table that you don't need it anymore. Otherwise, you're gonna delete that specific table forever from your data. So this was our quick review of the chapter 2, an introduction to SQL. So I hope you find it helpful. Please remember this review was by no means a comprehensive lecture. You will need to read chapter 2 thoroughly and do the assignments and conduct the queries there to fully understand the material and able to ace quizzes, exams, and assignments. And same as always, please make sure to contact me if you have any question and we can set a time and meet in the office hour time.